Okay, my pre-calcers, you guys asked me to do a video of the shortcuts. Here it is, okay? All right, so the first one, conjugate pairs. We know if they're conjugate pairs, they are identical, but one's a sum, one's a difference. If you would have done FOIL or the box or distribution, the first two are just going to wind up being that number squared. So you get 4x squared, right? If you would have done outer and inner, you'll notice they are additive identity. They're exact opposites. Or additive inverse, sorry. They're exact opposites. So they cancel. So then just looking at the last, you'd have this times this, which is always, because they're different signs, always going to give you a negative. And it's going to be that same number, squared. So that's giving us our 9y to the fourth. So if I were to take that and use it on the same concept here, I would take these two numbers and square them just like this is. Some of you asked me to use arrows in class, so there's that same concept, okay? Then the subtraction would come down because I have a positive times a negative, and then the last term squared, which would be my 1 squared, which we know is 1. So I'll just put a -1 at the end. Now, this concept is just doing x plus y squared, okay? So before I answer this, I'm going to come over to this one. The old way of doing it was 2a minus b, 2a minus b written twice. Again, first two is really going to take the first one squared, which you probably would not write that. You would write this. And the last two are now the same sign when it's a perfect square trinomial, so it'll always be positive. Whether it's a negative times a negative or a positive times a positive, it's always going to be the last term squared. So there's your last term squared, okay? But now the outer and the inner do not cancel. They double, okay? They double. So you'll have a 2a times negative b and a 2a times negative b. So that means you're really getting 2a times b, right, as a negative. You're going to have two of them. So I always do 2 times. That's your shortcut. You wouldn't have done that on these silly little easy ones that you've been doing for a few years. You would jump right to that. But use that concept to go to this part of the problem. So the first term gets squared, x squared. The last term gets squared, okay? But now, if I would have had x plus y times another x plus y next to it, I would have outer x times y and inner x times y. So I would have 2 x times y's. And because that's a positive, that's a positive. That's this concept, okay? All right, so I'll do it one more time on this. This right here, I'm going to take this first term, just like the 2a is the first term, okay? I'm going to take that first term, just write it once, and square it. I'm then going to bring down this subtraction, just like I brought down this subtraction. I know if I wrote this next to each other instead of squared, I would have the same outer as I have inner. So that 2 is going to come here. So I need 2 of the product here. So 2 of the product here. So I really have 5 times 2x minus y's. And then lastly, I have the -5 times -5, or -5 squared. Negative times negative is always positive, okay? So this cancels to 10. So I have -10 times 2x is a -20x, and a -10 times -y is a +10y plus the 25. And now this needs to get squared and brought down. So this is giving you that shortcut. Now, a third time, okay, on this problem. So we did it once here, we did it once in number 3, and now we'll do it again here. You're going to take the first term and square it. So 4x squared. You're going to take the last term and square it. So positive y squared. Then you get this product, a negative 2xy, but you're going to have 2 of them. So negative 2 times 2xy, which would become a negative 4xy. That's what goes in there, okay? So there's those. I know you wanted more, so let's quickly look over here. Okay, I'll jump to this problem. And this one I'm going to do as U substitution so that you can see that. So before I do that, I want you to look at this problem. If I gave you x squared plus 4x, okay? You see that there's an x common. You pull it out as a GCF and you're left with x plus 4. Easy peasy. Yes? You wouldn't write the x squared twice. You did back in middle school when you first learned this. You went x times x plus 4 times x. You found the common x, you brought it out. So this x was common, you brought it out here. There's your x plus 4 that's left for the parenthesis. Okay, we're going to do the same thing here. So same concept, you have 3x plus 1, 3x plus 1, plus 3x, whoops, remember we had to correct that? That was written wrong. It was 3x plus 1, okay? So you see that one of these is common. I'm going to just draw something on here to help you guys see this a little bit more. I know this video is going to be long, but I'm trying to be really thorough explaining it because you all asked for this problem, okay? So these are alike, okay? I can't do all 3. I can only do 1 on one side of this plus and 1 on the other side so that it's still kept as a binomial, just like up here. I could only circle 1 with that binomial. So that u is common. I'm going to bring that u out and have a set of parentheses. So in the parentheses, I have 3x plus 1 still left on this side. Plus, if there's nothing left on this side, you know you have to have the placeholder. We talked about that in class, and I think everybody understood that, so I don't want to have to go back over that. If you need me to, let me know. Put it in the comments, okay? So this right here simplifies to 3x plus 2 because you have a plus 1 and a plus 1. And now the